Welcome to the second workshop in this series, which I named Repeat, Repeat, and Repeat. That's because we are going to be doing a lot of repetition with various methods. So there's about 3 parts. The first section, I'll be covering how to use loops and how can we actually use loops to create some interesting visuals. And then the second sort of section is how to use functions, and what functions are and how you can use function to really help organize your code, and also how you can use functions more creatively. And the last part, depending on how much time we have, close to the end of the workshop, I'll demonstrate how we can save the processing, the P5.js sketch as a GIF. And first, I'll show you what's possible with loops. So I have one example for linear gradient. So if you check the code, I have like 26 lines of code, and that's including all the curly braces and everything. So even though it might seem like a somewhat complicated visual, it's just really a few lines of code. And that would be the first one. And then a different one is, that was a sort of a more linear one, from left to right, right to left. And then I also have a circular one that's fairly similar, except that I use some sine and cosine so that it's like rotates. Okay? I have to give credits to Zach Lieberman, which is one of the artists I referred to last in the previous workshop. One of his videos, which pretty much he did like a shorter version of this, so I was really inspired by that. So a lot of my work is also inspired by his works. Hopefully I get your attention, I get your interest, and let's figure out how I wrote all this. Let's start by creating a new sketch. So new P5.js sketch, and give it a good name, workshop number 2, and loops. Okay? Let's start drawing some, good old circles. How do we draw a circle? We literally type circle. So I'll write it inside of the draw function right after background. So a circle, let's say if I want to draw it at the center, I'll do width -2, which is half of the width, and height, not minus, divided by 2, and height divided by 2, and maybe 50. Okay, so that's one circle. And and believe it or not, the example that I showed essentially are like 500 circles. And how do you do that? You might, the easiest way is you can, just copy and paste. You can create like 100 of them. Or in programming, we have something called a loop. And one common one is called a for loop. It starts with the word for, and followed by parentheses. And inside of parentheses, we have 3 parts. Usually we use like a counter. If you want to repeat for 100 times, use a counter that starts with 0. In programming, it's more common to start with 0 than 1. So you start with 0, and then you count it by 1, so from 0, and then you do something, and then you count 1 and do something else, and then count 2, and so on and so forth until 100. So the first one, initial state. So I'll use a variable called I, which I believe it stands for index. So that's also just a convention that people usually use I for this, but essentially you can use any variables. This is just a name. You can use I, you can use X, you can use Y, you can use whatever. Okay, but as a convention, we use I. So let I equal to 0. That means at the beginning of the loop, I will be 0. And then the second part is under what condition should we run the rest of the code? Whatever code that's enclosed inside of a loop. So let's say I is smaller than 100. That means as long as I is smaller than 100, we want to keep doing this. And then the last part, commonly written as I++, or if I expand it, it's I equals to I plus 1. That means every time after you run this piece of code, what do? We increment I by 1. So starting from 0, it becomes 1, and so on and so forth. And again, this doesn't have to be 0. It doesn't have to be 1. You can increment by 10. But usually if you just need it as a counter, you increment by 1. Okay? So that's sort of the parenthesis part. And all the code you want to run, you want to put it inside of 2 curly braces. Okay? Also, you might notice that I'm adding like extra spaces. So depending on the program language, sometimes indentation matters. Like in P5.js, which is JavaScript, the indentation actually doesn't matter. But the indentation does help me to read the code a little bit easier so that I know that the circle is inside of the for loop. But otherwise, if I delete the extra spaces or put it at the beginning of the for loop, that still work. Yes, question?
Spaces between the letters and numbers important?
So some of them are important and some are not. Any of the sort of keywords that you use, there has to be space. For instance, this variable I, let is one of the keyword to indicate that I'm creating a new variable. So I have to have a space because let I would be regarded as one word. So that will not work. However, I equals to 0, you can remove the space because even removing the space, it's saying the same thing, I equal to 0. So as you read more code, you will get more familiar with which spaces are necessary, which are not. For instance, after equals I can add extra spaces. That all doesn't really matter. Okay, and one thing that you can use is inside of edit, there's tidy code that automatically it tried its best. It's not always what I want the code to look like, but it tries its best to format the code to be readable. Okay, so we've done that, the parentheses, and put everything in curly braces. That means it's going to draw this circle for 100 times. And if I run this, boring, still one circle. Why? That's because I'm drawing the exact same circle again and again on top of each other. So it's, you really can't see the multiple circles. So how do we make sure that you can actually see the different circles? You can use this variable I as part of, the sort of the construction of this circle. Instead of just, setting it to the center, I'm going to use I for the X value. You can use it for Y. That's also fine. But so now I've used I for X for the X position. So it starts from the left side of the screen and all the way go to the 100 pixel to the left side of the screen. Okay, but because of the stroke, it's just like a it sort of leaves at trace. We are going to add more color to that. So for now, I'm going to add no stroke at the beginning, so to turn off the stroke. So now you just see the white circle. Okay. So again, I think for now it's still fairly hard to really visualize, to really see all the circles. But be patient. We're going to get there really soon. So instead of 100, what about 200? Essentially, I make it's a little bit longer because now it's repeating 200 times, and you see how the x, because the x value is I, that means the last circle has x value of 200. Okay, and now if I set this to 400, it will go across the screen. Okay, so now we have 400 circles. And then how do we make it more interesting? And let's look at the height. Right now it's all at the same height. That's why it's a straight line. But we can add a little bit more. We can change the value of the height, or more specifically, we are going to use I as input for the height. Okay. So an easy way is to just simply add I to the height. And then you'll see that, remember in computer graphics, the larger the number, the larger the y value, the lower it goes. So now it's more of a sort of goes sideways, but that's not as interesting. Remember how I used the sine and cosine at the end of the previous workshop? Let's use sine and cosine. So I'll add a sine, and sine I'll use I as input. And then what kind of output am I going to get? again, it seems like nothing's happening. That's because sine is, the smallest value can be is -1, the largest 1. So that's why it's just changing 1 pixel, which you can't really see. So let's try to amplify it by multiply the sine by, let's say, 100. So 100 times sine. Now you see that it's going up and down. And again, but for now, the eye are really, really close. I mean, sort of the oscillation is really close. How do we make it a little farther apart? We can divide I by a number, maybe 10, okay? And maybe I just want it to be further apart, maybe 30. So now you can really see the sine wave, okay? That was by dividing I by 30, okay? So far, does anyone have any questions? Yes, everyone's following? Great. Okay. And now, I think let's add some color. Yeah, because when it's the same color, it's really just the stroke. Let's add a little more color. Okay. In order to add color, we want to have a fill inside of the for loop. That's because for each individual circle, we want to fill it with a different color. So instead of fill, for instance, if I put red, the whole thing will be red. But again, we can keep utilizing I as a variable so that the color changes based on I, basically the X position. So let's say let me just put I there, then it's a gradient. So it starts from I equals to 0, start from black, and all the way to white, okay? From black to the left side, and then white to the right side, okay? And then, again, believe it or not, I just use sine and cosine a lot. So this, again, I think I used a little bit at the end, near the end of the previous workshop. So with colors, the smallest value you want, you can use is 0. The largest value you can use is 255. So 255 divided by 2, it's 177.5. So you can use that, or I know I'm using 178 plus 177 times a sine, okay? Because this way, again, the sine part is multiplied by 177. So the lowest possible value in this section is minus 177. That would mean the whole thing will be 1. And the largest value is going to be 177. And the whole thing will be, that's 255, which is the largest value possible, okay? Run this. Again, it's a faster change from white to black, black to white. And we can also divide I by 20. Okay, so now it's a more gradual change. Previously, because sine changes for every 2 pi, which is essentially like 6.28, around 6.28. So for from I from 0 to 400, about 6 numbers it will change. It will have a full cycle from white to black. That's why, without this division, it changes the color really fast. I mean, if that's the sort of effect as you are going for, that's completely fine. But I prefer a little more gradual, gradient. And then I divide it by 10. You can just try out different numbers. If the smaller the number, the closer the gradients are. And the larger the number, the more subtle it is. Okay, I'll leave it as 20. Okay, and now we have grays, and that's because we've only been using one number inside of fill. So I'm just going to copy and paste, and I'll also use a tidy code so that this quickly line this up vertically. Again, the spaces in between didn't matter, so even though it's just the 3 colors, you can actually put it vertically so it's easier to read. Essentially, right now it's the same thing, so nothing's going to change. So I divided I by 20, and what if I change one of the 20 to like 19? Now there's a little bit of color. that's because now the RGB values are not changing at the same time. I mean, they're changing at a different rate. That's why, you know, there's a little more red, a little more green here, and a little less green there. Okay? And at this point, you can literally just play with the numbers, so you might have interesting effects. So I'm using 20, 19, 18. We can just try a set of other colors. Okay? Again, am I going too fast? Is everyone following? Yes? Okay. Seeing noddings? Yeah? Okay. And, you know, if I use like maybe 5, 6, 7, the color just changes a little more drastically, more saturated, and, you know, a lot more colors within the canvas. Okay. Again, I'll go with a more subtle look. So 20, 21, 22. Okay. So far it's not moving. Yeah. It's a colorful thing. It's a gradient, but it's not moving. How can we make it move? So there's two things we can make move. One is to make the circle size change, actually. Yeah, changing the circle size will be interesting. So for now, the size is just 50. Again, I'm going to add sine, cosine, yeah, and add this time I'll just use 50, and then 50 multiplied by sine something. I'll put I inside and give it, yeah. Okay, so I divided that by 20. Okay, and yeah, I think I lied. It's still not moving yet, but we do have more changes in sort of the thickness of the stroke, if you think of that as paintbrush. Okay, like basically different sizes of circles. Okay. So now if you want to move, the reason why it doesn't move is all the value that's used here, even though it changes from 0 to across sort of the x-axis, but it does not change over time. Yeah, if we want it to move, we need to use a value that will change over time, which is, okay, I just saved so that, you know, I don't lose it. And then one, you know, really useful variable is a frame count. You know, again, essentially give you the number of frames it has passed, it has lapsed. Okay, so I can add frame count. You know, I can add it at different places to have different effects. So for instance, if I add it here for the size, let's see. Again, if I don't divide it by anything, it's kind of probably going to be super fast. Yeah, it's like just flashing. I'll divide it by 10. Okay, yeah. So now it's moving, changing. Yeah, it feels like it's moving, but essentially it just changes in size. It's really not moving to the left or right. It's just changing size. Okay. If you want it to slow down further, it's 20. So more sort of soothing sound, sort of motion. Okay. So now so I'll copy this frame count, divide by 20, and the plus sign, I'll copy this. So now that was for the size, when I was animating the size. What if I added to the height? So not the height, the y-axis, but inside of the sign. Okay? Only if you add it inside of sign, that's where it has a more smooth. Okay. I think that's fairly similar. Yeah, I mean they're different, but essentially it feels like it moves up and down. Yeah, but that's like two different things that you can change. Okay, and then what if I add it to color? So maybe I'll add it to just a red color. You know, RGB. The first value is red. Okay, so you see how it's not moving. It's just a color. Okay, what if I add it to the second one? You know, the grain is also changing, and then the third one, all three different color changing, but that's changing at the same time. That's why it's roughly the same color repeating. So what if we just change the number? So 21, 22, okay, or maybe, and that's where the color really gets to start to become different. So I'll make it a little more different. So 20, 25, 30. Okay. So now it has, very different colors throughout, over time. Okay. And then what else we can do? We can do all of this at the same time. Yeah. So I'll paste it inside of the height, the y-axis. Maybe I'll line this up in 3, like vertically, so that you can. Okay, I'm going to move this aside. Yeah. So you can see that. So this is x. X, I'm keeping it as I, and we are only changing the y. I'm going to add the frame count instead of the sign for the y. I'm also going to add the frame count inside of the size of the circle. Okay. And there we go. That's essentially, the first example that I showed. The next one is actually really similar. Right now we are going with like a linear from left to right. Essentially for the x value it's I. The next one it's rotating. It's the same thing except we wrap that around. Maybe I'll give 5 minutes and see, see if you can figure that out. Or feel free to, it's with this kind of stuff, it's really not helpful if you are listening for the entire time and not, practicing. So I'll give 5 minutes just to try it out, just to change different numbers and see what can happen, or maybe add frame count to a different, to somewhere else and see what can happen. In the meantime, I'm just gonna walk around and see if people come up with interesting stuff.
I have a question.
Mm-hmm.
What does the numbers actually like? Is every number a color, or what is it?
So for fill, if fill is a function that changes the color for the fill of the circle. So there are 3 values. If you use one value, it's 0 to 255, and 0 being black, 255 is white. So anywhere in between is a different darkness of gray. And if you have 3 values, it's RGB. So the first value is like how much red you want.
Okay.
Yeah. So that's why, if you change number, there's different amount of red, different amount of green, different amount of blue, and then you have colorful things. Okay. Does that make sense?
Yeah, it does.
Okay.
Thank you.
Great. Okay. I'm really surprised and pleasantly surprised by some of the things that I've seen. Like everyone has like a different approach to this, like was able to make something that's really different, quite different from what I'm showing here. So let me get to the next one, the more circular one. Let me duplicate this one. Loops, circular. Okay. So let's start from here. And how do we make it a circle? Actually, first step, I'll remove all the frame count thing. Okay. Frame count. Okay. So there's actually, yeah, some of you might be wondering what I was doing. So there's a shortcut in P5 JS editor, and also in some of the text editors. When you want to edit the exact same thing at the same time, so I select sign. For instance, I want to change all the sign to cosine. Of course, you have the similar method as Word, Microsoft Word, where you can just find and replace. Or there's a shortcut, Command D on a Mac, probably Control D on PC. I'll select sign and then do Command D. It will select the next one of the same, exact match. And then I do it repeat that to select, all the signs, and then I can just type cosine. It will change all the sign to cosine. So I was just trying to remove all the frame count so that we start from still. Okay, so it's less distracting. Okay, so we have something like this, and how do we make it circular? Essentially, what you want is to not just having y value for the with the sign, but also the x value. So if I do both, remember how I also did something like this last time. When both are the same, it's more on the diagonal. So I basically just copied the y that I did, which is based on, psi I something. And now it's sort of a diagonal shape. And I changed one of them to cosine, and that's where you get a circle. But now, right now, it's not like a complete circle. To get a circle, you need 360 degrees. And in radian, it's essentially 2 pi. And in processing, conveniently, we have a variable that's called 2 underscore pi. Okay? So that will give you the complete circle. And times I divided by 30. So instead of 30, I'll divide it by, let's say basically the number of times looping, so which is 400 divided by 400, okay? So essentially for sine, if if the input is from 0 to 360 or 0 to 2 pi, it will go a full circle, or a complete sort of interval. And right now, so that's why essentially I want this number to start from 0 and end with 2 pi. And that's why I use I divided by 400. And that way, the smallest value I get is 0 divided by 400. The largest value I get is 400 divided by 400. So that I make sure that the value is going to be a number from 0 to 2 pi, which is one complete circle. I'll do the same for both sine and cosine. So again, we can just copy the same thing inside of the sign for the diameter. Now we have the complete circle. For one circle, it repeats the exact same thing for sort of once. So now if I want to have more repetition, I can just multiply this by a different number. So 5 times this, 5 times this. Oops, that's a little too much. Maybe I'll just add it again. I'll delete the 5 times here. I'll add it here instead, just to the size. Okay. So now that when it's 5, I know it has exactly 10 bobbly thing. Yeah. If you want, for instance, your number, the number 5 to match the exact number that you have for those little circle, then you can change this to pi instead. So 5 meaning you have 5 parts, 50 means you have 50. Oh, that's like almost, you can barely see that, and 10 is 10, okay? And let's try to animate this by adding the frame count thing, frame count divided by 10, okay? So now we have more like a circular gradient, okay? Divided by 100, it's much slower. That's too slow. Divided by 20 is about a good. And similarly, I'll add this to the other signs. That's too fast. I'll do 2, 10. Let's just try different values. Okay. That's too fast. So 40, and maybe 30. Okay. And this is where it almost has like a 3D effect, even though what we are doing here is purely 2D. Okay. Again, yeah. Once you have the basic thing set up, you can just try different values if you want it to be super, Now the color changes really fast. You can add this to the color. Okay, so now, yeah, previously the color is always that same set of color. As soon as I add the variable frame count to color RGB value, that's when the color starts to change. Okay, and then you can do multiple of this. You can we can do a lot of crazy things. And I remember one of the IM student was talking to me the other day, and she said she was initially a math major, and in like sophomore, junior year, she decided to major in interact media. So I can't even imagine what kind of crazy stuff that she can come up with if she learns how to use P5.js, like with all the math knowledge. And sometimes Wikipedia is a really good resources. So for instance, this is like an algorithm that use limited color to represent more colors. Yeah. And then this is one particular type of dithering. And then in Wikipedia article explains how, in pseudocode, explain how it works. Essentially someone already did the hard work. They figured out what you can do to make it work. And what you need to do is to translate that pseudocode to P5.js code. One of series of my work is actually based on that. So it's a pretty early one. So, yeah. So this is like similar stuff we did today, except that I add some dithering. So that it actually has a different effect. Like for instance, this one, this is essentially a circle that's smaller and larger, but I used that Wikipedia article and also used, watch some of the videos to learn how to apply dithering into my, into P5.js. So the next part, let's learn functions, okay? How we can use function. And again, I'll show you example that I created. And I'll just show sort of the last one. This. So essentially, it's just a smiley face, but I use some random functions, so it's keep creating more and more random, at random location with a random color. But I know this is more like sort of trying to create like a more friendly example, but obviously, you can also apply this and do something, that's more interesting to you maybe. Okay, and let's see how we can do this one. Create this. So again, we start with a new sketch, workshop number 2, functions. Okay. So anyone knows what functions is?
You don't have to write a piece of code every time. You just call the function.
Okay.
Once.
Yeah, exactly. So one of the sort of most basic or sort of feature or thing that the function can do is to save your time. Loop was one way to do it so that we repeat and with different variable. But then function is something that we can save a set of code and then reuse it. We've actually been using functions for, we've been using a lot of functions. We've been, the setup is a function, draw is a function, but also background is also a function. Background is a function that draws a background, and circle is a function that draws a circle. In the essence, what P5.js is as a library is they wrote a lot of functions for you, so that when you want to draw a circle, you can just say circle, specify the value, it will draw the circle. Believe it or not, if you just use JavaScript, you can create, you can pretty much create everything that you can create in P5.js without P5.js, but it will be harder. So in order to draw a circle, it's a much more complicated process. So someone wrote that set of, all the code for you so that you can just use these functions to simplify your process. And we can also apply that in our own, coding. So let's write a new function. Function, I need to write this function outside the other function that we already have. So start by function, and then we can give it a name. It can be any name you want. So similar to variables, when you have a set name, that name you shouldn't have a space, because once there's a space, it's think of that as two separate things. So two functions or two variables. So you don't want to have any space. When you have multiple words, there's actually two formats. I'll call it draw underscore smiley underscore face. Okay, and then parentheses and curly braces. So that's how same way you write the draw function. So this is one format, and the other format is called a camel case. So essentially, capitalize all the words that comes after the first word. Sometimes the first word is also capitalized, sometimes not. So draw smiley face. So how do we draw a smiley face? Circle, again, doesn't have to be smiley face, it can be anything. So circle, let's say 100, 100. So width and height, 100, 100, yeah, 100. Okay. Nothing's happening. And that's because this is a separate function that's never, so a function is a set of code that you wrote, but it's not, in itself, it's not doing anything. You have to actually call it to make it, to call it is to, let it run so that it actually does whatever you ask it to do. So by putting the name draw smiley face and parentheses semicolon inside of a draw, it will actually perform whatever action that you, whatever code that you wrote inside of that function. Okay, so circle, I have that circle, and then I'll add more circles as eyes. So maybe, let's see, 30, 30, 10. That's okay, right. 130, 130. That eye was a little too far. And this numbers are okay. 100. I see. So maybe 90. This is where I think I wasn't okay. And I want to move it to the left a little more. So the x value 80. Okay. And then the right one, maybe 120. Yeah. So let's just for simplicity, let's just use 3 circles because we need to change that really soon. So that's why I don't want to get too invested in this. So it's a face, and if I want to draw this once, I put it inside of a draw. If I want to do multiple times, I can simply repeat and repeat. But for now, it's not so helpful. This is one way you can use functions. Sometimes it's helpful to do this. For instance, let's say right now I put it in draw. What if we use like the other function that we did last time, function mouse clicked. Okay, so inside of mouse click function, every time mouse is clicked, I want to draw a smiley face. Draw smiley face. Okay, so whenever I click, it draws a smiley face, but that's because of the background, so I'll remove the background. So run this again. Okay, let me move the background inside of setup. So that does still have that gray background, okay? So whenever I click, it draw a face, but it's drawing at the exact same spot. If you just have a long, a set of code that you need to repeat, there are certain cases that you do need that. But what can be more useful is to add some parameters, what's called parameters. So in order to add parameter, essentially you need add some variable inside of the parentheses for the function. So for instance, I want to be able to change x and y when I draw this face, so x and y. And I might also want to change the diameter, so I'll use the d. Okay, so now we can assume that we always have x and y and d. And then where is the circle going to be? So you have to use only use the 3 variables trying to draw the same thing. So the face will be at x and y. That's x and y, and the diameter is d. Okay, so this circle, this I, it should be x minus d times 0.2. I think I'm starting to do a little more math, but essentially I'm just using these variables x and y and d, try to figure out where I want this circle to be. So now if I run this, you don't see anything that's because we didn't provide. So we have x and y and d in this function. Then when you actually draw a face, you need to, similar to circle or rectangle, anything, all the function we used, you also need to provide the exact numbers. So mouse clicked, I'll put it inside of draw so it always shows up, okay? So in draw, whenever you use this function, you do need to provide the x, y, and d. I'll just put 200, 200, okay? And face, I want it to be 100, okay? So that's sort of the x and y and the d that I'm providing for this function, and then we can use this, okay? So essentially I'm using the X. So I want this left eye to be to the left side of the, the center of the circle. So that's why it's X and X minus a number. And then I also want the diameter to be able to control how much I'm moving to the left. And then, so the other eye should be on the right. So that's why instead of minus, it's Y plus for the right eye. And then they're at the same height, which is a little bit to the top of the the face. And then for the diameter, maybe I'll use it like a third, or maybe again ×2. Let's see how big that is. D ×2. Okay, so that's about a fifth of the diameter. That means whenever I draw the eye, depending on how much the diameter of the face is, it will draw a different size of the eye. Okay? Is everyone following here, this part? Yes? Okay. And now, finally, with all this done, now we can create a circle at a specified location. For instance, if I put it at mouse clicked, so whenever I click, I want to put it at mouse X and mouse Y. Okay, now I can do that. So that I don't need to write, the same code again and again. Every time when I want to create a new face, I'm just calling that function and now providing the new information, which is mouse X and mouse Y, and we'll draw based on that. Okay? And one thing that you might notice in the example that I showed is I have like random size. The face sometimes is big, sometimes small. So there's a very convenient function called random. Random, if you put random here, so instead of 100 as a diameter, I'm using random, this function for the diameter, but you do need to provide, well, random, I think directly it will also sort of work, okay? So whenever I click, it will create a face, except it's tiny. Yeah, and why is it tiny? That's because this random function gives you a random number from 0 to 1. Okay, so that's sort of the default. By default, it will give you a random number from 0 to 1. Obviously, we want a number that's, if it's just 1 pixel, it's too small, so maybe we want a number from 0 to 100. So you add a number inside of random to specify, I want a random number anywhere from 0 to 100. Actually, it will never be 100. The biggest it can be is 99.999999, but it will never be 100. So it's exclusive of the number that you provide. Okay, so now if I click, it can be a face of any size from 0 to 100. Okay, and if I put if I put this inside of draw, I move around, it's random size, but of course we can also use random for the X and Y position. So random width, and random height, okay? So what this means is, remember that the number, if you provide one number, the number you provide is the maximum value you want this random number to be. So random width, that means it will be a random number anywhere from 0 to width, and the random height is the number anywhere from 0 to height, okay? So now if I run this, we have random sized smiley face, even though, it's not actually smiley, but, random. Yes, question?
With the random sizing, can you put a lower limit?
Yes, absolutely. And guess how you provide a lower limit? You can just use 2 values. So right now, sometimes the face is probably too small. Then you can do 50, 100. Then the 50 will be the lower limit, and that's inclusive. So it's possible that will be 50. Okay, that's just a little bit sort of technical detail for you, but most of the time you probably don't really care, whether that number will show up or not. Okay. So same for the X and Y. So for instance, if I put 200 and comma, then it will only show up on the right side. Okay, that's because I made sure that the lower limit of the x value is 200. Similarly, I can do 200 for the y, then it's always on the right corner. Okay, and I do want to have it for the whole canvas, so I'm going to delete that. Okay, so that's random position and random size. Okay, let's also add random color. Yeah. How do we add random color? We use fill to fill the color, and then random 255. So it will be a number anywhere from 0 to 255. Okay, so for now, again, it's just start from grayscale. And if you add, simply repeat this time we don't even need to do anything extra, because every time random is run, it will create a new random number. Okay, so I simply give random 255 for both RGB value, and it creates random, random color. Okay, and I might want to emphasize on the stroke, so I'll change the stroke weight to a little bit higher value. Again, that's just the aesthetics I want to go for and make it a little bit thicker. Okay, and for instance, if you want to have only lighter colors, what you can do is, because the lower the number, the darker it will be. So you can provide a lower limit. So maybe 200, 255, 200, 255. So the lowest value is going to be 200. So now it's just very light colors. Okay? The same thing if you want to go with dark color. Okay? And also, as a sort of a bonus, we also, besides RGB, we can actually change the color mode. By default, it's RGB, but you can change it to HSB. There's HSB and HSL. They're a little bit different. Not going to get into that, but essentially, you can change how you want to, how you want to represent color. Now it's it's different. That's because for HSB, instead of 0 to 255, H refers to the hue, which is a number from 0 to 360. If you ever color wheel, that's just how people decide to represent color, where it's in a circle, so it's 360 degree. That's why it's a number from 0 to 360. And 0 and both 0 and 360 is actually the same thing, which is red. So you can control the hue. And then there's a S, stands for saturation. So color picker here. So this is essentially you are picking the hue here. So this is a hue. You see how, if you look here, they have the HSV. V stands for value. So the angle, sort of the hue is always a number. As you move this, this number goes from 0 to 360. So anyway, so hue and then saturation, and then you have the B for brightness, or L for lightness. Is there a V? No, I think it doesn't support the V. So in P5.js, whenever you have like a keyword, for instance, when I put width and height here, the color changes. So I was just testing HSV, and it doesn't change the color. That means that's not one of the color mode that's supported. So HSB and HSL. Okay. So saturation is a number from 0 to 100, and brightness is also a number from 0 to 100. Okay. So now let's say I want to have all kind of color. So 0 to 360. That gives me all the colors on the, on the color wheel. But I want it to be very saturated, which is going to be, you can specify the exact number, or you can use, random number. So very saturated, maybe from 80 to 100. So it's going to be at least 80% saturation. And then the brightness, I also want it to be very bright, so 80 to 100. Okay, so now this time we have all different colors, but we sort of eliminated the darker colors. Okay, and more instance, maybe you want to have less saturation, like 0 to 20. Let's see what it looks like. Yeah, so a somewhat similar effect, but this way you actually have more control over. Yeah, the other one is a little more random, but this you have a little more control because you can specifically specify the saturation, the brightness. For instance, I want this to be dark, then I can go with 20 to 40. Then it's all very dark colors. 180, and then maybe I only want like a red color. So just from 0 to 30, it's different type of red, but it's you know, on the color wheel, that's the hue that I want. You know, then you can just change the hue, whatever range that you want to specify what color you want to have. Any questions? Okay. If you want to stop, okay. So essentially it depends on how you want to use this. Right now I'm just, you know, because I put it inside of a draw, so it keep going. You know, if I put it in mouse click, it will only draw when I click the mouse. And if you, let's say you want to draw 100 of them, then remember that we have the variable called frame count, okay? Oops, so draw, let me make this a little bit bigger so it's easier to read. So draw smiley face. When do you want to draw? If you want to draw 100, when do you want to draw? You want to draw it only if frame count is smaller than a number. Let's say 100. Only if it's smaller than 100. So anywhere from 1 to 99, that's actually going to be 99. You know, 99 faces. So 101, and put this function in. Oops. Okay. Put this draw smiley face inside of the frame count, inside of this if it's condition. So what will happen is only if frame count is smaller than 101, you will draw circles, and afterwards you won't draw. So let's give it a try, and it stops because it already reached. Yeah, it reached 100. Okay, and every time, actually, there's one other thing we can learn. You see how every time is actually different. Maybe it's easier to see with a smaller number, so 10. So every time it's like every time it's different. However, in some cases, it's useful if you want to make sure that it's random, but you also want to have some control that like every time you run it, it's the same thing. It's a random place, but it's also a set of random position that you have control over. That's when you can use something called a random seed. So function random seed, inside of this function, you add any number. Essentially, you are using this number that you are provide as a seed for the random function. So whatever function, whatever number that you provide there will decide. So that's also why this random function is not true random, because you know if it's random, then y is going to be, so now it's going to be the same every time I run it. So it appears to be random, but essentially it's, again, some mathematician figure out this algorithm to produce something that seems random, but then we also have control over it, so which is really helpful at some time. Yeah. So usually for this kind of random function, by default, what is using as seed is the time. That's why every time we run it, it's a different time, so it generates a different series of random values, yeah, which appears to be random, but you can actually control it. Okay.
Would it be the same to use a
A for
for loop?
loop. So with a for loop is somewhat similar, but remember that the draw function runs multiple times every second. But the for loop, if you use a for loop, it's going to happen within the same frame. So the only reason why we can see the process of drawing more is because every frame you are drawing one face. But if you use a for loop inside of a draw, that means you are drawing 100 faces at the same time. So that's when you won't be able to see that process. So in the end, it's the same image. It's depend on what you're trying to achieve. If you want to create a video of that process, then go with the draw, put it inside of draw. If you just need the final result, then you can use the for loop. Okay? And the last part, I'll demonstrate how we can save save the processing the P5.js sketch as a GIF. So let's just make a little bit larger value, maybe 500. Okay. Besides mouse clicked, we also have key. I think it's not clicked. It's called key typed. This is a function that will run whenever you type anything on your keyboard. And I'm using this because this is when I will trigger the same save GIF function. Because if it's clicked, then whatever that I accidentally, if I accidentally click, it will start to save. So usually it's less likely to trigger if you use key typed. And that's also because we will be able to specify which key we press. So key type, let's just demonstrate key typed. So whenever key typed, let's say we can just use a circle to demonstrate 200, 200, 200, okay? And so because now we are inside of editor, so if you type any key, it's actually changing the code. So the first thing you need to do, you need to click on the preview, our canvas, and then you can type a key. So I type some key and draw that circle. Okay, so very similar to mouse clicked. But now we want to specify which key we typed. That's with the if statement. So if key equals to, we need 3 equal sign, 3 or most of the time both 2 equal sign or 3 equal sign works, but just to be sure, 3 equal sign is safer. So that's just something unique with JavaScript. In most programming languages, you use 2 equal sign when you want to compare if 2 values are the same. But in JavaScript, 2 equal signs are a little more loose about the comparison, and 3 equal signs ensure that the 2 are the same. So if key equals to S for save, okay, and then we would draw this circle, okay? So I run this, I click on my canvas, I type whatever key, nothing's gonna happen, so I don't accidentally trigger this, and I press S, that's when it draws a circle. And also, it's also a random circle, so I can actually, circle of random color, so that I can also, play with that too. But more importantly, we want this to be the trigger for save GIF. If I remember it correctly, I think it's literally save GIF with a capital G. And yeah, the function is called save GIF. And where is that? GIF? Actually, I don't remember. Let's see. So we need 2 arguments that we need to provide. One is the name of the file. So just faces, I'll call it faces. And the next one is how many seconds you want to record. So let's say 3 seconds. Okay, let's run this. I'll click here and press save. Okay, and it's saved as a face.gif. Okay. Yeah, so now I have a GIF. And apparently one thing I just noticed is when you press save, it sort of restart the sketch. So if you do want that sort of light gray background, you can put, maybe, let's see if this works. I'll put the light background here, so save. Okay, that actually didn't work. Maybe alpha, yeah, because this is a very new function they added. Okay, that's weird. So I think, yeah, either it's still buggy, or it's not. Yeah, it's not doing what I hope it was doing. Yeah. So I think the behavior is a little bit, and also they're not random color. Is it not random color, or maybe it's just because the color are really similar? Yeah, I don't even think it's random color. So unfortunately, we learned this the hard way. It seems like this function is still, not very reliable. But maybe that's just because of the specific thing we are doing here with random. But I did try to save something else and it worked. Like with the gradient, for instance, I think it worked. But do remember that GIF usually doesn't have a lot of color, like essentially the color depths. So try to use a small set of colors so that it's a small file. Statistically, the quality varies depending on what you're trying to do. So this is it. Thank you for coming to the workshop, and I hope to see you next Tuesday. Yeah.
Thank you.
Thank you. Thank you.